Okay, so get myself squared away here. Whoops, that's not what I wanted to do. Good afternoon, everyone, or good morning, depending on where you are, or good evening. Welcome to today's free webinar, Quality and AI-Based Systems, with our guest speaker, Adam Leon Smith. I'm Rex Black, president of RBCS. We are a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. And since 1994, we've delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services for companies that are looking to improve their test and quality assurance practices. As I said, today we welcome Adam Leon Smith as our guest speaker. Adam is CTO of Dragonfly and is focused on testing, quality, and AI. With 2 decades of experience in environments, development, testing, quality, and project delivery, in addition to commercial experience, he is the chair of the British Computer Society's Special Interest Group in Software Testing and works with the International Standardization Committees developing AI and quality-related standards. Also, I'll mention that Adam is the editor and I guess lead author, is that what you would be, of the forthcoming book, which I think, at least the working title, was AI and Software Testing, if it hasn't changed. And that's coming out January?
Probably January, I think, yes.
Yeah.
I've got a picture of the cover later on in the presentation.
Oh, very nice. Yes, so good. I'm sorry, did I just spoil the ending?
Don't worry, Rex.
Okay. So today we're going to talk about AI quality and testing, and AI is a very complex topic and is the biggest technical renaissance to impact testing for at least 2 decades, if not one of the, say, more momentous technical advances in perhaps close to 100 years. I mean, the thing that I think of as most similar in terms of global impact to AI is the invention of a process to make nitrogen-based fertilizers and other nitrogen-based chemicals out of airborne nitrogen, which may not seem like a big deal, but ammonia is a big deal. And about half of the people in the world today live on crops of food that could not have been produced without the help of the chemical fertilizers that are made due to the process that was invented over 100 years ago. So AI has a sort of similar possibility to be disruptive in both good and bad ways. And so today, Adam's going to talk about some intrinsic quality issues with AI, some challenges in testing AI-based systems, and some new techniques and methods. And he's going to talk about some emerging AI-enhanced testing tools that are yet to get much coverage. So if you have questions during the course of the webinars, please feel free to submit them, and we will try to get to them at the end. But I know Adam's got a jam-packed session here. So Adam, over to you.
Thank you very much, Rex. And hi, everyone. So yes, I'm here to talk about AI and quality and testing, which is a really complicated topic. So I'm only going to be able to give you in this session a taster of some of the different subtopics, if you like. But I'll point you to some resources that are available where you can find out more. So Rex has already introduced me. My name is Adam Leon Smith. I won't go over my bio again. I'll get straight into the content. So AI has become a must-have for every business. Everybody is doing it. You know, I don't walk into any company, any startup, any enterprise these days where they don't either have a data science and AI team or they have a plan, a strategy around AI. It's being used all over your house, on your phone, in your workplace. And you know, it really has become as ubiquitous as the World Wide Web, certainly on track to be. So what is it? Well, loosely we can define it as applying acquired knowledge to make decisions or predictions, in contrast to specifying how those decisions are actually made in logic. This fact means that it has unique quality and testing issues. Part of it is about the challenge of verifying the behavior of AI through testing. Part of it's also about using AI to improve your testing. And the big challenge that industry has is convincing everyone that AI systems can be trusted with important decisions. And this is a really important topic to testing, which I'll come to at the end, particularly if you're in Europe or providing products and services that are imported into Europe. So just to talk about the difference again between the logic that we use in traditional software, where we process input data, execute the logic, and have some kind of output data or action. If we look at a machine learning system, and I don't know if you can see my cursor, but on the left, we have model parameters and input data, which go into a training process where a model is trained and then deployed as part of a larger system. And then additional code is used to feed data to that model and produce the output data. So you essentially have a whole separate task, separate to the programming, which is the development of a model. And the inputs to that are not just code, but a whole set of training data. So they're quite distinct in terms of the way we build these systems. Machine learning is by far the most commonly used AI method. It's not the only one. There are plenty of other methods that are used for lots of different things, but it is the most common one that you'll come across. And machine learning engineers and data scientists themselves have identified that the two biggest issues they have are testing and quality assurance and decision-making with customers. And those are kind of related because a lot of it is about specifying what we expect the system to do. They also identified the lack of an oracle and imperfection in the actual systems as top causes of this. On the screen, you can see some of the research areas that are being given a lot of focus at the moment in machine learning that relate to testing. The lack of an effective oracle is the biggest. And the second is the identification of adequacy criteria, or as you might call them, pass-fail criteria or expected results. So this is something that the research community has clearly identified as an area where they need to invest effort into, which is great because there's a lot more R&D we need around testing machine learning systems compared to the wealth that we have on conventional systems. Another aspect is online monitoring and validation. Systems change, they change by themselves, and the context changes as well. So that's a really big area of focus. They sometimes call it AI ops, or they might call it continuous monitoring of models. Other issues include faults and how we actually debug problems, how we avoid regression issues. When you change a model, you're changing the whole model. It's not like conventional software. You can isolate the change to a small subset of the code and test around that. When you rebuild or retrain a model, everything is potentially changed. Another issue is the cost associated with thorough testing of AI systems and the complexity. So I'm just going to run you through 10 problems. These are, I think, the top 10 problems relating to AI testing and quality. The first one is if there's less specification, how will we define the tests? If people simply throw data at models to come up with predictions without specifying what they want, that makes it much more difficult for you to specify expected results and acceptance criteria. Another problem is if we don't know the answer and we're writing the AI system to find out the answer, how will we test it? How do we measure test coverage? Because we're dealing with a very data-driven system. We're dealing, in the case of artificial neural networks, we're dealing with things like neurons that are intended to at least attempt to mimic the human brain. Test coverage is not the same. We're not going to be able to look at statement coverage, decision coverage in the same way. If the system's continually optimizing itself, how will my tests change it? So this has happened to me in real life, where I've been using a cloud-based shared AI as a service system, and the regression tests I run every night started to change the system. It started to optimize to the tests I was running and regressed in areas I wasn't testing. Additionally, if the system is optimizing itself, the amount of resources it's changing and its expected behavior can change significantly without anyone deliberately trying to change it. If the system's intended to mimic human capabilities, what are these human capabilities? When we think about things like chatbots, for example, it's very difficult to define everything a human might say to a chatbot. Of course, if you're dealing with something like an e-commerce system, you can predict a lot of that. But the more complex the system gets, the more difficult it becomes to define human capabilities. And there is a tendency to not define those, which makes it very, very difficult to test. Bias. So all ML models are biased based on the data used to train them. But is that bias appropriate? Is it bias that you want? AI bias has been talked about in a lot of different forums, so I'm not going to delve too much into this topic, but the first ISO/IEC deliverable has just been published on bias in AI systems. And it is something that is very relevant to testing, because the only way you can find bias is by testing for it. The correlation between inputs and outputs changes over time. You think about models that predict footfall, foot traffic in shopping malls, and what happened when the pandemic hit and the lockdown came in. The correlations in the real world change, and the model suddenly drifts away from its intended purpose and becomes less accurate. Again, this is a reason why continuous testing is needed with a lot of AI systems. Is the behavior of the system ethical or fair? There's a whole field of ethics around AI. Some of it's sci-fi, some of it's real. Should AI be being used to determine, for instance, unemployment benefits and whether they're awarded to individual people? What level of human oversight should be in that? This is less of a testing problem, but we may have ethical or regulatory requirements that we need to build testing frameworks for. What if it's trusted too much? So if a system is recommending something to you and you're approving the result, research has shown that your decision degrades by at least 5%. I think it's higher than that. I've observed this in UAT cycles, where things work great until you expose them to users, and the users start accepting recommendations from the AI system that are incorrectly. Think about autocorrect. What if it can be tricked? You can trick AI systems by changing the way that data is fed into them. You can trick AI systems such as facial recognition systems with simple pixel changes that make you look like whoever you want to be. There's at least 3 different vulnerabilities, security vulnerabilities, that are completely unique to machine learning systems. And of course, they're exposed to all the other vulnerabilities, the server they run on, etc., that other systems are also exposed to. So at the moment, there's a lot of talk about AI quality and testing, but now we're starting to really work in international forums to try and define the quality aspects of AI. Some of you might recognize this diagram being a modified version of the SQUARE standard, ISO/IEC 2510, which I use all the time for determining test strategies with clients that I'm working with. Quite a lot of things change when you add AI. And in the standards community at the moment, they're trying to rationalize this diagram and figure out exactly what is different and what the terminology should be. And there's lots of disagreement between the research community and the standards community on words like transparency, explainability, interpretability, where people have different understandings of what they mean. So don't take this diagram as a final version. It's got another year to go of people really defining the quality characteristics of AI systems. And that includes societal and ethical risk mitigation, which is a very important factor, particularly in some countries and some cultures at the moment. There is one standards deliverable, a technical report that came out last year, guidelines on the testing of AI-based systems. And this is likely to be turned into a more formal standard over the next couple of years. And some of the topics that it touches upon are combinatorial testing. How can we apply combinatorial testing to AI systems? Certainly the way we do combinatorial testing now doesn't apply at a code level, but you can use some of the techniques from combinatorial testing to help design tests in slightly different ways for AI systems. But the research on that is minimal compared to the amount of research that's available from the 90s in conventional systems. Back-to-back and A/B testing are 2 types of testing that can be employed within the verification of AI systems to help avoid the problem of not having effective oracles and expected results. Metamorphic testing is a testing technique that's been used in biology and things like genetics for a while, and is now becoming popular to apply to AI systems. And there's even a derivation of that called datamorphic testing, which is sort of combining that with a form of test automation. I mentioned before around coverage, we measure coverage differently. There's a whole set of definitions in this document about things like sign change coverage and neuron coverage and threshold coverage that are specific to the way activation functions work inside of an artificial neural network. But again, they are ways of measurement. There's very little evidence out there that they're effective. There's very little research, very little industry use. So I'm not going to have time to fully explain combinatorial testing, but essentially it's a way of testing different parameters together to reduce the number of test cases that you need to run. We know that a significant number of failures are caused by specific interactions between different parameters. And a lot of people will run pairwise testing or all pairs testing to try and leverage this benefit of this research that we know that these are the things that are most likely to find bugs. So essentially, you can rationalize down what would be a very large set of tests, exhaustive testing of this number of inputs, this number of configurations would be 81 configurations. But with pairwise testing, you can get that down to like 9, and you'll find most of the bugs. We cannot apply that research and extrapolate it to AI because of the way it is implemented at a low level. But we can use that kind of technique to help design tests. For instance, if we look at self-driving cars, we could apply that technique to parameters like inputs from each sensor, weather conditions, road conditions, time of day, visibility. And it can be an effective way to reduce the number of tests. But as I say, whether it finds the optimum number of bugs is as yet unknown. So metamorphic testing has been around since 1998. It's a testing technique that always requires multiple executions. It establishes heuristics. So these are actually called metamorphic relations, which you use as a dynamic test design approach. And unlike conventional testing, running one test can identify another test. So there's an example below that where you're using ML, machine learning, to predict the likelihood that a person will have a disease that predominantly affects older people, you know that there's a heuristic, a metamorphic relation relating to age. So therefore, a test design could stipulate that you'll significantly increase an age on an input record and identify whether that generates a higher likelihood of diagnosis in the outputs. Another example of metamorphic testing is if you're testing a website that has some search and filter functionality. If you search for a narrower set of filters, you should find less results. That kind of heuristic can be applied to AI systems, and it is, I would call it a type of exploratory testing. I would call it similar to exploratory testing. Now, I also mentioned that you can get a lot of benefit from using AI in your testing process. So one example is test data generation and synthesization. So this is an example of an AI-generated human face. Have you ever needed to use pictures of humans in your testing and worried about data protection and getting your passports and things off your testing staff? I have. Well, there is a solution to that. Now you can generate test data. This is one example. There's lots of other different types of test data that you can generate in more machine readable formats as well. You can use AI for defect triaging and analysis. If I switch to my browser tab, I can show you an example of that in real time here, where this system called Neuro is able to identify the developer that's most likely to be appropriate to fix a specific issue at the point of it being raised. It can also spot things like duplicates that have been raised in Jira. This tool's called Neuro, and one of the things we're building next is actually, there we go, is actually a test prioritization function where we're analyzing Git commits, source control commits, and we're looking at the developer's experience with that component and various other metrics and predicting where testers should focus in a new release that they've just received. Other examples for use of AI is test generation, effort estimation, object recognition and identification. So I've got a demo that I won't have time to show you using Selenium with a machine learning model to identify buttons on a screen on a website and using the images rather than using things like CSS references to identify the different components on the screen. It's also used in visual testing, identifying visual bugs, comparing multiple systems. So I mentioned standards a couple of times. As I said, there is a standard on, there is a technical report on the testing of AI systems. It's likely to turn into a more developed standard over the next year or two. There's a quality model for AI-based systems, which is being developed. Just published a few weeks ago is Bias in AI Systems, AI-aided decision-making, which does include a lot of guidance on testing. Robustness is another issue. There is one standard out there about formal methods for assessing robustness, and there is another one coming out about empirical methods. And risk management, which is obviously core to any test strategy, is a standard that's going to be published quite soon. So you may be aware that a few weeks ago, ISTQB released their first AI testing certification. RBCS has been offering an A for Q course for a little while now. And there were actually 3 courses worldwide that were talking about AI testing and proposing solutions and training people over a number of days. ISTQB has now amalgamated all of those courses and now has the new international standard course, which I'm sure RBCS will be offering in due course. So I've only got a few minutes left, but I want to talk about what's going on in Europe, which you may or may not have heard about. At the moment, there is a proposal on the table for the AI Act, which is due to come into force in 2024, should lawmakers agree it, but they are expected to. This will apply to any system that uses statistical techniques, machine learning, or AI, any system that may affect European persons. It applies to suppliers of systems, providers of systems, and users. So not end users, but users as in people that buy systems and implement them. It prohibits specifically certain types of AI, manipulation of human behavior, social scoring, indiscriminate surveillance, etc. But there's a large number of common use cases that it classifies as high risk, which might include access to education and training, recruitment, task allocation, credit scoring, eligibility for public services, a whole range of quite common use cases for AI where people are using machine learning right now. And these high-risk systems have to go through quite a rigorous process. They will require conformity assessment prior to being placed on the market. And central to that conformity assessment is technical quality management systems and testing. There'll also be a public database of registered systems. They'll be required to use error-free and unbiased data sets in the training and testing. There's even requirements on logging and how much logging there should be. And there are also requirements on how things are communicated to users, including test results. You will have to, if you're selling an AI system, you will have to write a detailed testing report and provide that as part of this. So this is very relevant because the majority of the compliance aspects that are introduced by this regulation are expected to be testing related.
And if I could just mention one thing here for those in the United States who are thinking, yeah, that's Europe, this doesn't apply. You remember GDPR came out in Europe, what about five years ago, 6 years ago, something like that, and was almost immediately followed up by a carbon copy of that law in California. And that is now spreading. So if you're thinking, yeah, we don't do business in Europe, this won't affect us, don't count on that. These laws, once promulgated, serve as model legislation that ends up flowing really across the democratic countries anyway.
That's right. And as I say, it will impact any American company that is providing services into Europe, so Google, Facebook, etc. will have to comply. It also includes new permissions about when you can use test data. It will, things that you're prevented to using under GDPR, you will now be allowed to use for testing. So an example of that is sensitive data such as race, and that's to prevent things like bias. So there is some things in there specifically to make testing easier. For some systems, they'll have to be independently tested by a third-party auditor, and systems will be stamped with like a quality, a CE mark, which is like, if I look at my chair, there's a CE mark on it saying it meets certain standards. So very interesting developments over here, very interesting technical developments, a lot going on in the standards community. I think this is a really fantastic topic. If you are interested to hear more, I have a podcast called Fuzzy Quality, which is on all usual systems. And as Rex mentioned at the start, this book, Artificial Intelligence and Software Testing, is, I think it's in the coming soon page on the British Computer Society's website at the moment. It will probably be available in January. If you have any interest in seeing more of the tool I was demonstrating, you can go to myneuro.ai. And if you've got a general question, that's my Twitter. Feel free to send me a message or tag me or something. And I think we've got 2 minutes right now if anybody has any questions.
A luxurious 2 minutes, yes. Yeah, so we have a question here from, I'm looking over at my screen, from Mary, who asks about the compute time intensivity of AI and ML systems, especially during training, which then, of course, requires power, which is generally carbon intensive. And then she asks, is it possible to make the training less power intensive so as to reduce the footprint, if you will, the carbon footprint of AI systems during their training?
Fantastic question. So yes, so machine learning uses less precision mathematics than general purpose computing. So it's possible to use processors that use less power, called GPUs or ASICs. That's one aspect of that question, of the answer. But another part of the answer is it is a really big problem. It can take, to train certain models, it can emit as much carbon as 125 transatlantic flights.
Wow.
Think about that. That's crazy. I mean, these are big
crazy.
models used by like Google and things like that.
Mm-hmm.
But at the end of the day, it really comes down to how the data centers are powered where the AI system is being trained. And if you look at the carbon emissions from the data centers used by the big cloud providers, they're not the most carbon efficient. If you can, there's some countries such as Germany, whose national power system is more carbon efficient than some of the big tech companies' cloud computing data centers. So yes, models need to be optimized to take less training, but also the way we power our data centers and our compute is also a really big issue.
Great. Interesting point that you raised about regression risk being higher. So I hadn't really thought of that before. I take it that this is sort of an ongoing area of study, because not only are the set of possible tests could be very large for an AI, but then if any time the thing changes, and of course it doesn't have to be changed by people, it can change itself. If that means, we need to rerun all of the regression tests, that's a pretty big hurdle. So what kind of research is going on there, just briefly, that to try to contain that problem?
So there's some research around trying to understand the difference between two iterations of training a model, but we're a long way away from being able to use that to optimize testing. Mm-hmm. It's also, as I said before, you need to continuously test models after they're in production. Mm. Because other things change, the data changes, the context changes. Right. And that's probably a bigger area where people are looking at that issue and doing research around identifying changes in models. So short answer is we're likely to be learning a lot of interesting things over the next couple decades as these continue to become more ubiquitous in terms of, oh, wow, we hadn't realized it was going to do that. Yes. Yeah. So hopefully not learning anything like the surprise that people got in the Terminator movies, where Skynet wakes up and decides to kill everybody. That's just a movie. I'm hoping we're quite a long way away from that. Yeah.
Okay, well, very good. Thank you so much for your time, Adam. Appreciate it. And thanks to everybody for showing up. We will have the recorded version of this posted very soon. Just keep an eye on our usual social media locations to get access to the recorded version. And then there's also the podcast that'll be out. So everybody, again, thanks for joining. I hope you all enjoyed this free webinar from RBCS. We do these as a service to the software testing profession because at RBCS, we are a not just for profit company. If you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. Happy to provide a quote for any such help that you might need. You can contact us at info@rbcs-us.com. So again, Adam, thank you very much. Appreciate you taking time out of your day to do this, and enjoy your evening. I guess it's about time to have a pint or whatever you're ready for over there. Yeah.
Yeah, certainly is.
Okay, good. Thanks very much.
Bye-bye.
Bye.